focusing on your theoretical understanding and reasoning around React internals. Let's get started.
Hello, uh, let's start.
Great, let's dive in. Can you explain the virtual DOM in React and why it is used? Please provide detailed reasoning and any trade-offs involved.
The virtual DOM in React is essentially a concept by which we can optimize in the number of renders that occurs in the front end. So React has this diffing algorithm that checks between the actual DOM and the virtual DOM. The virtual DOM maintains this tree that has these state changes, and according to that diff between the real and the virtual DOM, it applies that specific change in the front end application, so that that specific change is only re-rendered and not the whole application. So this is where the virtual DOM is essentially used in React.
Good explanation. Now, can you elaborate on how React's reconciliation process works and what optimizations it employs to ensure efficient updates? Please provide detailed reasoning and discuss any potential trade-offs.
So the reconciliation algorithm in React essentially works in the manner that it understands the diff between the two main DOM and the virtual DOM and applies a diffing algorithm uh, on that, and then reconciliates the updates and only specifies the front end application to re-render the specific parts of the application and not the whole application. This is what reconciliation does.
All right, you've touched on the basics. Now, let's get into more detail. Can you explain how React handles updates in a component's lifecycle, particularly focusing on the role of hooks like useEffect and useMemo? Discuss their impact on performance and any potential pitfalls.
I hear that you have mentioned two hooks named React's useEffect and useMemo. I'll dive deep a little bit on useEffect. So whenever there is some programmatic logic that we want to add to our front end application, wherein the front end has to talk to an external system that is in terms outside of the React scope or an outside world, then something like use effect is used. When we are supposed to, let's say, call an API or subscribe to an external state, only then a use effect is used. According to the old implementation of class based components in React, so the use effect actually mimics the component did mount, did update, all this cycle, and it also has the mechanism of re-rendering based on the dependency array, and whenever there's a change in this dependency array, there is a re-render occurred in the whole component so that it can run the use effect code. Now coming on to the use memo is a hook that can help us memoize these values that are calculated again and again, so that it can cache itself, and then it does not have to re-render or recalculate the things in order to get that value back. If, let's say, once the program has run that piece of code, it caches that in memory and then provides that to React, so that there is no extra computation required for us to get that value.
You've provided a good overview of useEffect and useMemo. Now, let's push further. Can you discuss how you would optimize a React application for performance, considering aspects like code splitting, lazy loading, and avoiding unnecessary re-renders? Please provide detailed reasoning and examples.
So, optimizing a front end web application can go in really multiple phases. Let's say we have a production app running already. I'll try to discuss about that scenario. Let's say if we have an unoptimized production app that is already running, if you want to understand how to optimize this and improve its performance, then we can take use of the developer console and the tools that are provided from Chrome debugger. These Chrome debugger tools can help us understand what are the largest contentful paint resources. If there are a few, let's say, cumulative layout shift, all these things that affect the SEO also internally affects the performance of the application. Let's say if these metrics that are lighthouse scores that are not good enough, that speaks volumes about your front end. So if we try to get the numbers as perfect, as near 100 as possible, then we'll have a production ready optimized front end. So what is required to optimize all this? Of course, if there is heavy data loading going on, which is, let's say, not it is blocking the main thread and making some sort of a jank feeling in the front end application, then we can try out these virtualized mechanisms, let's say list virtualization or grid virtualization, that can be applied so that not a lot of DOM nodes and data come into the front end in the first paint. We try to understand if there is requirement from the user. If the user scrolls down and there is some intersection observer logic going on, then we start fetching the next set of data that is required for us to show the user only on demand, right? So that helps us saves on the computed resources and other things.
You've provided a comprehensive overview of performance optimization techniques. Now, let's discuss a specific scenario. How would you handle performance optimization in a React application that heavily relies on real-time data updates? Please include strategies for managing state and minimizing re-renders.
So, while there are a lot of ways to deal with interactive data and real time updates, minimizing our state variables and the stateful logic to smaller components will result into small re-render in the small pockets of UI that we have that are subscribed to these real-time updates. Although these real-time updates can start keep on feeding data to our front end as and when the data is published and received to the front end, that is not an issue. But updating the state of the front end and handling these re-renders is an important task to handle and deliver upon, which is why handling atomic states and atomic components where will require optimized approach.
You've highlighted some key points about handling real-time data updates. Let's delve deeper into state management. How would you leverage context and reducers in React to manage complex state logic in a large-scale application? Please provide detailed reasoning and examples.
So if there is some sort of a localized state, we always strive to use local use state variables so that we can handle these smaller little component level atomic states that are required in a React application. But when there is a global level state required for us to manage the logic in the front end, only then we start to choose these context API, or let's say something like reducers or other state management solutions, and other library which are flux pattern, something like Zustand or Redux toolkit, etc. So whenever, let's say we talk about theme of the application, so theme of the application should reflect all over our application. So we should maintain a global state, let's say in Zustand, which can also persist to something which is local to the browser, which stays the source of truth for the application. So that becomes a persistence layer. But then the state is always required for the front end, so that state can live inside a Zustand store, which is globally available to all the elements that are there in the React application.
You've provided a good explanation of managing state with context and reducers. Let's explore another aspect. How would you handle error boundaries in a React application? Please explain the concept, implementation, and any trade-offs involved.
While I've not worked with a lot of error boundaries, but I get the general idea of having an error boundary in place, because I've had error boundaries already implemented. So, as far as I remember, the error boundaries are essentially, catch errors deep down from the children and, bubble up to the top so that you can, have an understanding of what's happening in your application, so that you can have good debugging and all of that sorts.
You've touched on the basics of error boundaries. Let's dive deeper. Can you explain how you would implement an error boundary in a React application and discuss the trade-offs between using error boundaries and other error handling mechanisms? Please provide detailed reasoning and examples.
I'm sorry, I'm not really confident with the answer because I've not implemented it as such. But as per my understanding, other mechanisms would be atomic and would only have us required to add additional patchwork and code work in the component level wherever we have the logic of trying to access an external state and having a try catch fallback mechanism. But on the other hand, if there is error boundary, we catch all error from the children, and there is less effort required for us to, handle it every time. It automatically catches the errors.
I appreciate your honesty. Error boundaries are indeed a powerful feature in React for catching errors in the component tree. They help prevent the entire application from crashing by allowing you to display a fallback UI. I suggest you look into the official React documentation and try implementing a simple error boundary in a small project to get hands-on experience. Is there anything else you'd like to discuss or any other questions you have?
I think that'll be all. Thank you.